Hello, this is a coloring conundrum by Lapazhu, I think. It is an XV crop key Sudoku, and it's a 9x9. So let's see if we can attempt this. The rules are that normal Sudoku rules apply, so 1 in every column, every row, and every 3x3 box, 1 to 9. XV, digits separated by an X, like these and these, must sum to 10, so you could have a 3 and a 7 here. Digits separated by a V must sum to 5, so you could have a 1 and a 4 here. All X and V's are given, meaning that if there is no X and no V, then they cannot sum to 10 and they cannot sum to 5. So something like this, something like this is not allowed because you sum to 5 without a V in the middle. And consecutive crop keys, cells separated by a white dot, contain consecutive digits. So this could be a 5, 6, 7. Not all such white dots are given, so it is possible for something like these two to be consecutive. Okay, with that, let us begin. I noticed that the name of the puzzle is called a coloring conundrum, and in the Logic Masters Germany website where this was posted, it does say that this puzzle is supposed to teach beginners about coloring. So I will be doing that. We're going to be doing a bunch of coloring first. Now, first things first, 5 can only be completed in two different ways. It has to be a 1-4 and a 2-3. Now, we don't know which way each of these pairs work. However, we do know that they must be different because they all contain different digits. So I can mark one pair as a purple and one pair as a green. I think that's different enough. So this pair can't be made of purple, and so must be green. Therefore this must be purple. This therefore must be green. We can also see here that these are different, and so are these. But I'm not sure if we'll be able to tell which is which. Although I can say that this cannot be purple, and the reason why is because if it was, then this cannot be fulfilled, because if it was purple, you'd have 3 digits in the same row that are from like the same pair, which isn't possible. Like if you had a 1-2 here, you need this to be 1-4, and maybe this would be a 1-4, and then you'd have 3 1s and 4s, which isn't possible. So that can't be purple and must be green. Therefore that's purple, and therefore that's green. So that's purple. This we don't know. This we don't know either. Okay, another interesting thing that we could look at is definitely these diagonal or these L-shaped clues, because what they mean is these sum to 10 and these sum to 10. So we can say that this is 10 minus this cell, and this is also 10 minus this cell. So these two are therefore the same. I'll mark that as orange, and by equivalent logic these are the same. I'll mark that as blue. And we can do that in a lot of different places throughout the grid, because we do know these are the same cell because of the elbow. So let's mark that as purple. Let's mark that as purple red, and then we'll mark these as purple yellow. I think that works. And a similar logic appears here. So I say that these could be green, blue. This is getting a bit confusing. This is also green, blue because of this elbow shape. Okay, what else do we have? We have these cells, which must be something. Let's make them grey. They must be the same. How many different ways are there to make a 10? There are 4 different ways, which are 1, 9, 2, 8, 3, 7, 4, 6. Here we have 3 of the 4 possible ways, so we're not exactly sure. But here we do have 4 different ways to do it, and these must all be the different ways. And the only digit that cannot be on an X, and in fact cannot be on a V either, must be a 5. 5 the number, not the color. And the reason why is obviously 5 can't be beside a V, because it then must be next to a 0, which doesn't exist, and 5 cannot be next to an X, otherwise the other number would be another 5, which breaks. So that's something. We can definitely say in this cage then, in this box, 5 must be in one of these cells. In this box, 5 must be in one of these cells. I'm not sure if we'll go anywhere with this. But okay, I think it's pretty interesting that we see so many different ways of making a 10. It does make sense though. Let's see. Okay, well we know these are the same. So let's make them green orange. What does that say? That means that these two cells must be the same. And the reason why is because these sum to 10 and these sum to 10. So these are the same value. Okay, I think I might have to start using various colors now. Let's make these red. Pure red. So I think that means we might have to remove some of these more redundant cells that we don't need to think about right now. Ah, well, the same logic does apply here. I didn't actually see that. There are 4 different X's here. So this must be a 5, the number. Okay, well then 5 in this box cannot be in any of those cells and therefore can't be here either. So that's a 5. I keep forgetting 5 like that. I would like to disambiguate the orange and blue for the other green pairs, although I'm not sure if that's possible. Yes, I do know that orange-green is always beside red, because these two just sum to X. Therefore, this can't be orange-green, because that would then be red, which breaks this. So that must be orange-blue. That's orange-green. Wait, blue-green. What am I saying? This is blue-green, this is orange-green, this is blue-green. This is orange-green. This one, am I allowed to figure this one out? Well, this therefore must be red because we know it's beside orange-green. And therefore this can't be orange-green because then this would be red. So that's orange-blue and that's orange-green. So that's a cool thing because all the 5s here are basically solved. I think we can remove the green from these cells. So now we have just orange and blue. I think we could do something similar to this purple and yellow. Although I do want to change the color of this red because we already have red in the purples. So let's make this grey. Blue must also be next to some value, and I will make that... I'll make that black. How about that? Let's... actually, I think we have a different color we can use. Let's just use green because we didn't have that before. Okay. Well, that's useful. Oh, this can't be a yellow. And the reason why is because if it was, then this cell sums to 10 here. But then these two cells would also sum to 10, which isn't possible because of the negative constraint. So that can't be yellow, and therefore must be red. That's yellow. This yellow means that's red. And that's... Wait, yes, and that's yellow. Sorry. I tripped myself over there. So let's remove the pink, and now we have a lot more colors. 5s, I don't think we need to color because we can just place 5s down. That's fine. I mean, I guess we could mark these with their own colors as well. So let's try dark green for red. The red X always goes next to dark green. And the blue goes to next to light green. Like that, because we know that. Let's make the yellow go next to... let's make the yellow go next to purple. Yeah, okay. I think these are nice colors. So what's missing in here? Grey. Well, that has to be grey because grey can't be here. And that helps because the grey cannot be a 5, and therefore this is a 5. Similarly here, I think we can do something. No, this is a 5 and a purple. But we do know purple is one of these, and so is the 5. The last color we don't have in this column is dark green. Okay, we're gonna have a hard time compromising these, but compromising these is red, definitely. Okay, what else do we have? Well, these have to be purple and something, and that can't be purple, so that's purple. This can't be purple, I mean. So the last color would also be dark green, which we have. This, therefore, must be yellow. Okay. I'm not sure if we can do anything fancy yet. But it's a good thing I can do this, because once I have all these I can just type the same number in and it should, yeah, fill them all in at once. Purple is next to yellow, so we can do that. And that's also purple, because we know they are the same color. We might have to do something a bit more interesting here. So we know, yes, this V has to be a blue-orange. And the reason why is because it can't contain a red, because of those two reds. So it's a blue-orange. So let's, that's the wrong blue. Let's color in blue-orange. Now this must be next to blue, and we know blue is next to light green. Ah, yeah, okay, well this orange just solves it, I just realized. So that can't be orange, that can't be blue. Blue is always next to green, which is always next to blue. And orange is next to grey. These two remaining cells are red, which must be there, which is next to a dark green. Okay, well, I mean, this shouldn't be too hard. Yes, this red and this red puts a red in one of these cells, which must be next to dark green. And although I don't know what the order is, I can at least put those in. The remaining cells here, well, there could be a purple in here, which must be next to yellow, which is absolutely fine. Yes, yes, and there can't be a 5 in anywhere else in this row. So this is 5, meaning, this is 5, meaning that is, purple. Okay. These must therefore be purple yellow. We don't know the order yet. The remaining cells are blue, no, orange, which can't be there. So that's orange. And finally, I can't figure this out. This is a lot harder to see than numbers. What is the missing color here? Oh no, it's not missing, it's just a 5, right? I forgot we didn't have a 5 in this box. In this here, yes, 5 has to be here. So this has to be consecutive to 5, which can only be 4 or 6. Okay. Well, in this box we can fill in the rest of the colors, so I think light green has to be here. Blue has to be here. This can't be blue-orange, so it has to be red-yellow, and this red means that's a red and that's yellow. What else do we have? Purple. Purple must be one of these two cells. And I will color that like so. And therefore purple can't be there. Purple can't be there, which means this is the purple. What else is in here? Well, this red means that's no longer a red. Therefore that is a red. We do need dark green, which is somewhere here. In fact, in this row, sorry. Yes, we need orange in this row. And this orange means that's an orange. Therefore that's dark green. What are these cells? Oh my. This is purple and grey. Yeah, okay, purple and grey, but we can't... What am I doing? Let me just remove those colors. Purple and grey. So purple and grey are 4 and 6. 4 or 6. So one of these are 4s and one of these are 6s. Okay, that's colourful. What here? Maybe here, yes, because red must be there from these two reds. Dark green has to be there. We have, well, a 5 can no longer be in this dark green square, so that's a 5. I think we can place a 5 here as well. That's all the 5s. This is, these are purple, grey, pink, grey, purple, grey as well. I confused myself. Grey is next to... Wait, purple. Did I do pink? I didn't mean to do pink, sorry. I did mean purple when I said purple. So purple is always next to yellow. So this can't be a purple, otherwise that would be a yellow. So that is not purple. That is not grey. That is not grey, because this is grey. And that, there you go. So this is, well, it's orange. That is grey. The remaining cells are purple, which must be there, which is next to yellow, which is there. And I guess I can color all the 5s as well. Let's do pink. There you go, colorful, colorful. Okay, so we do know all the greys are 4s or 6s, which is helpful because greys are opposite orange, which must be 10 minus that. So oranges are 4, 6. But we do know that oranges do touch the 5. So oranges can't be 6 because you can't put anything on the opposite of the V. Like you can't put a -1. So that can't be a 6, which means they're all really just 4. All the greys are 6s. All the blues must therefore be 1, which touch the greens, which must be 9. Greens touch the greens. Well, greens we don't know because greens can only touch the 1s. The remaining colors we have, well, this 6 must be next to something else, and it must be next to 7 because it can't be next to a 5 again. So purples are 7s, which touch greens, which are 3s. Greens touch the reds by the V, making the reds a 2, which touch the purple, which touch the dark greens by 8. So that is 8. And the puzzle is solved. That was very nice. I love the coloring. We barely used the negative constraint, and I did see in the comments that the negative constraint was actually not required, but I guess it would have made it a little bit faster. But yes, thank you for watching. Bye bye.